All right, let's kick off this deep dive. We're taking a closer look at all things React state management today. All those docs you gave us, we're going to pull out the highlights, the really important parts about how React, handles state.
Sounds good.
I think if you're listening to this, you're probably pretty interested in this, probably for work reasons, maybe just out of curiosity. But either way, we're going to break it all down for you.
Definitely. I think the goal here is really to break down those core concepts
Yeah.
and most importantly, help you understand how and why you'd actually use them in your own projects.
Yeah, that makes sense. So one of the first things that kind of jumped out at me was this whole idea of reacting to input with state. In the docs, they use this cool analogy of like a designer making mock-ups, right? Instead of just writing code to like directly manipulate the UI, you're kind of describing these different states, almost like swapping out those mock-ups based on whatever the user does.
Yeah, I think that's a great way to put it. I mean, I think this whole declarative approach is a core part of React's philosophy. Thinking visually about those UI states can really help you to keep your code cleaner and easier to manage in the long run.
Yeah, and it totally clicked for me when I saw that example of the quiz form. You know how they use a status variable to control like the submit button and the success message?
Mm-hmm.
It's like so cool how the UI just reacts to those changes in the status. But I guess my question is like, doesn't this approach get super complicated as the app grows?
That's a great question. And it can, which is why choosing the right state structure from the get-go is so important. The docs, they even warn about like redundant state variables, like having a full name variable when it's really just derived from the first name and last name.
Oh, yeah.
I mean, it seems obvious, but I bet we've all done it at some point.
Right. Oh, totally. I had this aha moment when I realized you can just calculate those values during rendering instead of storing them redundantly.
Mm.
And the document even says, and I quote, many bugs are fixed this way.
Huh.
So simple, but powerful, right?
Right.
Just by simplifying your state, you can avoid a ton of headaches later on.
Absolutely. I think a well-structured state is really the key to maintainability. And that leads us to the challenge of like, well, how do you actually share state between different components, What happens when two components need access to the same piece of information?
Right, because two components fighting over the same state, it's like two kids fighting over the same toy. They both want to control it and things get messy. The solution, I guess, is to lift state up, right?
Yeah.
It's like a parent stepping in and taking control of the toy.
Exactly. So you're lifting that state to a common ancestor component, and that component becomes kind of the single source of truth. It decides when and how to share that state with its children.
And the accordion component example that really made this clear for me, instead of each panel, managing its own open or closed state, the parent component, it keeps track of which panel is actually active.
Wow.
And the panels themselves, they just get instructions. It makes the data flow so much clearer. So you, the developer, you're like the architect of how information flows through the whole app. You get to decide who gets access to what.
Yeah, I like that. I think that's a great way to think about it. It really helps avoid a redundant state, keeps those components in sync. But, sometimes React tries to be a little too helpful. Remember that chat app example where the input field doesn't reset when you like switch recipients? I was confused by that at first.
Oh, yeah.
Because React tries to, preserve and update parts of the component tree that match up between those renders. It's all about efficiency, but sometimes you do actually need a component to like fully reset.
So how do you override that default behavior then?
Well, that's where the key prop comes in. Think of it like a unique ID for each component. If you change the key, React thinks, oh, this is a brand new component, I better reset its state. So like in that chat app, each recipient could have a different key, and you'd get a fresh input field each time.
Okay, that makes sense. But I'm thinking as we add more features and complexity, things get pretty overwhelming. What happens when you have a bunch of components with their own like event handlers all trying to update the state? That sounds like a recipe for chaos.
You're right. Managing all those updates, it can be a real headache.
Yeah.
That's where reducers come in. Think of a reducer as this dedicated function that handles all those state updates, but just for one part of your application. It's like having a central control center for your state logic.
Okay, so instead of having all those state updates like scattered all over your component, you have this one central function, the reducer, that takes care of everything.
Precisely. So instead of directly modifying the state, your event handlers, they dispatch actions, which are basically just messages that describe what happened. And then the reducer, it looks at the current state in that action, and it figures out how to create a new updated state.
Yeah. The code example for the Prague itinerary app that really made this clear for me. The reducer, it neatly handles like adding, changing, deleting tasks, keeps everything organized. So whenever you find yourself juggling lots of event handlers to update state, a reducer might be just what you need to bring order to the chaos.
Exactly. It's a great way to centralize your logic and make those state updates really predictable. But what happens when you need to share state between components that are like really far apart in the component tree? Because passing props down through multiple levels, that can get really messy.
Oh, yeah, the dreaded prop drilling problem, right?
Yeah.
Doesn't sound fun. What's the alternative there?
Well, React provides this powerful feature called context. It's basically a way for a parent component to provide data to its entire subtree, no matter how deep, without, explicitly passing it down through props. Think of it kind of like a global announcement system.
Oh,
Yeah.
okay. So it's like a shortcut
Yeah.
bypassing all those intermediate components.
Mm-hmm.
But wouldn't that make things harder to track though? If data just appearing out of thin air?
It's a valid concern. While context is powerful, it's important to use it carefully. Think about those family tree diagrams, right? Traits like eye color, they can be passed down through generations without each parent explicitly listing them for every child.
Right, it gets inherited. And
Yeah.
they use the example of a heading component figuring out its level by asking the closest section component above it. It's like the heading is asking, hey, what level am I on? And the section component, it provides the answer through context.
Exactly. Some common use cases for context are things like theming, managing the current user, and routing. But like you said, it's powerful, but it needs to be used strategically. Too much context can make your code harder to understand.
So it's a balance. Context can simplify things, but it's not always the right solution.
Exactly. Now imagine you could combine the power of reducers with the convenience of context. So you could have a parent component managing state with a reducer, and any other component, no matter how deep in the tree, could access and update that state, but via context.
Okay, that sounds incredibly powerful. And is that where the Day Off in Kyoto app comes in?
You got it. That code example really shows how elegant this approach can be.
All right. Let's take a breath and kind of recap what we've learned so far. We started by talking about like thinking in terms of those UI states, which helps keep your code cleaner and easier to manage. Then we dove into structuring your state effectively, avoiding redundancy to prevent all those pesky bugs.
Right. And then we talked about lifting state up to manage that shared state and keep your components in sync. We even learned about how to use the key prop to like force a component to reset. And of course, we explored reducers for, centralizing that state update logic and context for sharing data without prop drilling.
Phew, that's a lot to take in. But here's what I'm wondering. If I were to like start a new React project today, how would I know when to use, each of these techniques?
That's a great question, and it's one that we're going to keep exploring as we delve even deeper into state management with React.
Okay, so we're back and ready to go even deeper into React state management. Last time we talked about some of those core concepts like lifting state and reducers, but the document, it also mentions these mysterious escape hatches, and I'm dying to know more. What are we escaping from?
Yeah, the name might sound a little dramatic, but it's not as intense as it sounds. Escape hatches are basically just ways to kind of step outside of React's typical rendering cycle. They let you like tap into those lower level browser APIs or handle more complex logic that maybe doesn't fit neatly into React's, declarative model.
So it's like we're breaking the rules a little bit.
Sort of.
When would you actually need to do that?
Well, think about things like animations or integrating with, external data sources. Those often require you to kind of interact with the browser in ways that React doesn't directly handle.
Okay, that makes sense. But wouldn't that make our code like messier and harder to manage?
That's where custom hooks come in. Remember those built-in hooks like useState and useEffect?
Yeah.
Well, custom hooks let you basically bundle up reusable logic, including those escape hatches, so you don't have to repeat yourself.
For custom hooks are like creating your own specialized React tools.
Yeah, exactly. Like, for example, imagine you're building a chat application. You could create a use chat room hook to manage that connection to the chat server. And inside that hook, you might use useEffect to subscribe to events from the server, which is like, using an escape hatch to communicate with the outside world.
Okay, and then any component that needs chat can just use this use chat room hook without worrying about all those low-level details.
Exactly. It makes your code much cleaner and more modular. And here's where it gets really interesting is you can even pass information between different hooks.
Wait, hold on. Different hooks can, like, talk to each other. How does that work?
Okay, so let's say our chat app. It lets the user like configure the server URL.
Hmm.
We would store that URL in state using, use state, right?
Right, because the user might change the URL.
Exactly. And we can pass that URL to our custom use chat room hook. So whenever that URL changes, our hook will know about it and it can react accordingly.
So it's like these hooks are having their own little conversation, passing data back and forth to make sure everything stays in sync.
You got it. You can even pass event handlers to custom hooks, like use chat room could take an on-receive message handler, so each component can define how it wants to handle those incoming messages.
Wow, custom hooks sound really powerful. But you mentioned earlier that context should be used carefully. Are there like similar guidelines for custom hooks?
Absolutely. I mean, don't feel like you need to extract every bit of logic into a hook. Sometimes a little bit of duplication is okay, especially for simpler tasks. I think overusing custom hooks can actually make your code harder to understand.
So when does it actually make sense to create a custom hook then?
I think a good rule of thumb is if you're writing a use effect hook, consider whether that logic could be reused elsewhere. Because effects are often used for things like, fetching data or setting up subscriptions, which are like perfect candidates for custom hooks.
Okay, that makes sense. It keeps
Hmm.
your components clean and those side effects a lot more manageable. Speaking of which, are there like best practices for, naming and structuring those custom hooks?
Definitely. So always start your hook name with use, followed by, a descriptive name in camel case. That just makes it really clear you're working with a hook.
Right, it's like a signal saying, hey, React magic is happening here.
Haha, exactly. And I think also focus on concrete use cases. So like
Hmm.
use data to fetch data from an API, avoid creating generic lifecycle hooks like use mount or use is mounted because those can make your code harder to understand.
Okay, that's helpful. But I want to like clarify something. Custom hooks, they let you share logic, but not like the state itself, right?
Yeah.
So if multiple components use the same custom hook, they each get their own like separate instance of that state.
That's a crucial point. Each call to a custom hook, it creates a brand new instance. So if you need to actually share state between multiple components, lifting state up is still the way to go.
Okay, that distinction is really important. I'm starting to see how all these pieces fit together. But wait, didn't we skip over useMemo and useCallback? Those sound familiar, but I can't quite remember what they do.
You're right. We did kind of breeze past those. They're all about optimizing performance. So think about it. If you have a component that's doing some complex calculation, you don't want to repeat that calculation unnecessarily if, the inputs haven't actually changed.
Right, that would just be like wasting time and resources.
Exactly. Use Memo lets you basically memoize the result of a calculation. So React will store the result, and if the inputs are the same next time, it just returns that stored value instead of recalculating. It's like caching the result.
That's so clever. So
Yeah.
useMemo is for values, and useCallback is for
Functions, it's great for when you're, passing functions down as props. By memoizing the function, you ensure it only changes when its dependencies change, which can, prevent unnecessary re-renders.
this is all making me rethink how I approach state management. It's a whole new level of control and efficiency.
It is, and these principles will help you write, cleaner, more performant React code.
Mm.
But believe it or not, we've still got more ground to cover. Remember how we talked about using context for specific parts of your application? Well, there's actually a way to take that even further with custom context.
Custom contests. Okay, now you've really got my attention. What makes them different from like regular context?
Yeah.
Okay, we're back for the final part of our React state management deep dive. Last time we got into those escape hatches and all the power of custom hooks.
Yeah.
Now we're going to venture into like custom contexts and even some third-party libraries. I feel like we're about to unlock the secrets of the React masters here.
I like it. As your applications, they grow more complex, you might find that that built-in context API, while useful, it doesn't quite cut it for managing, all those moving parts. That's where custom contexts come in.
Okay, so remind me again what's the big advantage of like creating our own contexts?
Imagine you're organizing a huge library, right? Instead of having like one massive room with all the books just jumbled together, you create those specialized sections, history, science fiction, so on. Each section kind of becomes its own little world.
Oh, okay. So with custom context, we're kind of breaking down our application state into smaller, more focused chunks.
Exactly. Let's say you're, building an e-commerce site. You've got state for like user authentication, the shopping cart, the product catalog, and so on. Instead of cramming all that into a single context, you could create separate contexts for each domain.
So like a user context, a shopping cart context, a product catalog context,
Yeah.
each one managing its own like piece of the state puzzle. I can see how that would keep things organized.
Yeah, precisely. It makes your code easier to understand and debug. Components only interact with the contexts that are like relevant to their functionality, so you minimize the risk of conflicts or, those accidental side effects.
It's like each part of the app has its own like dedicated team
Yeah,
focused on their specific area. But I imagine even with custom context, you could still hit a complexity wall at some point, right?
right.
Especially in really large applications.
You're absolutely right. And for those, really big, intricate applications, you might want to consider bringing in the heavy hitters. I'm talking about those third-party state management
Oh
libraries.
yeah, the big guns. We're talking Redux, Stand, Recoil, all those. What makes those libraries so special?
Well, they offer, more robust tools and patterns for wrangling complex state logic and data flow. They often introduce concepts like a global store, actions, reducers, and middleware. It's all about structure and predictability.
Redux seems like the most well-known one. Can you give us like a quick overview of how it works?
Sure. Redux, it uses this single immutable store for your entire application state. You update that state by dispatching actions, which are really just plain objects that describe what happened. And then reducers, they process those actions to produce a new updated state. It's a very structured one-way data flow.
Okay, so it's like a central command center for state management. Actions come in, reducers process them, and the state gets updated accordingly.
Precisely. And that unidirectional flow, it makes state changes very predictable and easy to reason about, which is super valuable for larger teams.
But I've heard Redux can be pretty verbose, requiring a lot of like boilerplate code. Is that true?
It can be, yeah, especially for, smaller projects. That's why libraries like Stand and Recoil have kind of gained traction. They offer similar functionality, but with a simpler API and less overhead.
So it's kind of a trade-off then between power and simplicity. You choose the tool that best fits your project. But how do you even begin to choose from like all those options?
That's the million-dollar question. I mean, it really depends on your project's, size and complexity, your team's experience, and your specific state management needs. I would say experiment with different libraries, read the documentation, try out some examples, and see what clicks for you.
Sounds like there's no one-size-fits-all solution. It's all about finding the right tool for the job and your own like comfort level.
Exactly. State management, it's a constantly evolving landscape in the React world. New libraries and patterns are emerging all the time. So stay curious, explore, and always strive to write clean and efficient code.
Well, this deep dive has been incredible. We've gone from like the fundamentals of lifting state all the way to these advanced concepts. I feel like I have a much deeper understanding of how to manage state in React now.
That's great to hear. And remember, this is an ongoing journey. Keep experimenting, keep learning, and don't be afraid to try new approaches.
Well, that brings us to the end of our deep dive into React state management. We covered a lot of ground from simple techniques to those powerful libraries. The key takeaway here is to choose the approach that best suits your project and your team. Thanks for joining us, and happy coding.